Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So many types of applications involve managing text, whether it be a customer relationship management system where fields of data and notes are stored about individual customers and sales opportunities, or content management systems where entire paragraphs of text are published to a blog or some other web-based presentation application. Mastering string manipulation is a vital skill, so in this lesson I'm going to demonstrate several common string manipulations that are made easy by the .NET Framework class library string class and some built-in features and functions of Visual Basic as well. So to begin with, I'm going to create a new project called strings, and we know that we need to surround a literal string like this, dim my string equals my so-called life, with double quotes. But what if we needed to put double quotes inside of the string itself? So we want something like this, but you can see when I do that, I get a blue squiggly line. Visual Basic is confused. It thinks that there should be the end of the line, but we kept on typing after this first closing double quote. So how can we remedy this? Well, fortunately, you can escape the double quote sequence by just providing two double quotes next to each other. This will create a single double quote in the string itself. And doing that twice will produce the results we want. So now let's just print that out to the screen with our common answer to all problems, console.writeLine and console.readLine. And you can see what the result is, my so-called life, and it's formatted properly. And so there are several occasions where things like this will happen. For example, let's show another example where we dim my string equals what if I need a new line in between of this little paragraph here. Now this makes it easy if I just use WriteLine twice, but what if I want to store that value or use it in some other capacity? I want that new line to be embedded inside of the string. So what I can do is this. There's actually a couple of ways to do it, but I'm just going to choose one. There's a constant called VB new line, and I'll just kind of insert it in there using a ampersand, then the VB new line constant, then another ampersand, and then the rest of my string. And it will look like this whenever we run the application. Okay, great. And similarly, what if dim my string? What if I need a tab in my string or in my line? Well, then again, I can insert VB tab, another constant built into Visual Basic. Let me get rid of this. That allows us to format our text correctly. So whenever I run the application again, I add a tab, I don't know what, 5, 10 spaces, a blank space in between what if I need a and tab in the line. All right, great. So there are constants for lots of purposes in Visual Basic. There's actually a full list here. If you go to this URL, it will take you to MSDN, where there's a full list of Visual Basic constants. Some of them are used for formatting strings like we've seen here, and some of them are used for lots of different purposes. At least you can kind of see the scope of the built-in constants in Visual Basic for these sorts of purposes. All right, let's go ahead and move on and talk about String.Format. We've done something like this before, so dim my string equals String.Format. So yes, the string data type has some built-in features. The format is one of them, as we've seen before, and we used this kind of string replacement code in the past to, I guess we could call it, do a merge between arguments that we pass in and the template, the very first argument that we pass in. And we use these curly braces with a number to indicate a zero-based set of arguments that will come after that template for the remainder of whether it's console.writeLine or string.format. So we know what this will produce if we run our application. We are familiar enough with that. But what you may not realize is kind of the extent to which you can go with this. Let me demonstrate one other example here. And we saw something like this before, but for the sake of building on this idea, let's put a make, a model, and maybe something else there. So we'll do a BMW 745 Li, and we'll give it the year as well. So we can mix data types and still depend on the string.format to merge them in nicely, like you see here, where we have this template with the make and the model, and we're actually able to pass in strings and integer values or numeric values. All right, great. But we can even go beyond that and do some advanced formatting. So let's set up another quick example here. So dim my string equals string.format. And here I'm going to use open curly brace 0 and then a colon. And what I want to do in this case is format these numbers, 23.35, as a currency value. So notice that it puts the $ before 23.35, which is a decimal value. And so this formats the number as a US dollars and cents format, since that's the preferred language on my computer. So you can set the language preference programmatically for your application. Otherwise, the .NET Framework runtime will use the language preferences from the computer to properly format numbers for the given country where your user is executing the application. All right, so there are several of these little pre-built formatting codes, I guess you could call them. And so let's take a look at a few of the popular ones. Say, for example, we have, we'll come back to that. We have just a long number. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And what if I want to format that as a series of as a decimal value, all right, with 2 values after the decimal point? So I would use the N formatting character to do that. All right, so you can see it formatted it with decimal places, but then also with commas every 3 numbers. So what is that? 1,234,567,890 units or whatever's. Okay, great. Let's kind of take that same idea. I'm just going to copy that line of code and paste it in here. And what if I want to use this same format, but let's just put a period in there and see what we get with regards to the P code. You can see that it formats this as a percentage, a very large percentage. Maybe we need to, and notice that it rounded this up from 0.78 to 0.9, okay? So that's interesting. What if we just wanted to do something like 0.123? Let's see what it gives us in that case. 12.30%, all right? So it essentially multiplies our number times 100 and then applies the percentage sign, okay? So what if we need to format a series of numbers into a string, such as a phone number or a social security number or a tax ID or something along those lines? Well, you can create custom formats by using the pound sign to represent the next number in the sequence. Now, I'm going to do this twice. I'm actually going to mangle this formatting the first time. So after the colon, I'm just going to start adding pound signs to represent a phone number in the United States. And I'm going to actually leave off 1 digit. There should be 4 pound signs there, but I'm going to leave it off. And I'm going to attempt to run this the first time, and I would expect it to leave off a character, but notice that it doesn't. It formats kind of from right to left. So it goes 098, 765, 432, and it has nowhere to put the 1, so it puts it at the very beginning of that string. Now again, that's not what we want, but I wanted to illustrate what happens whenever we format the string incorrectly. To remedy this, I'm just add one more pound sign and then it will look correct on screen. Area code 123 456 7890. All right. So that's how we can do some advanced formatting. And there's a small set of examples here, but it's a very large topic. And so if you want to learn more about the different types of formatting that you can perform on numbers using String.Format, take a look at this MSDN article where they talk about these different formatting codes that you can include after the colon for a given replacement value inside of your arguments for String.Format or console.WriteLine. Great. Let's comment that out and move on. So previously we showed examples of string concatenation using the ampersand operator, and we've used it quite a bit up to this point in our series of lessons. So the code example that we're going to write next will take this to the extreme, and we're going to use an iteration statement to just keep on appending strings to see what we get, and we'll talk about what happens in memory when we do that. So here we go, follow along. Great. Okay, so let's run the application and see what's happening here. All right, so we might expect this to be the result where we have dashes and then each index from 1 to 100 in between the numbers, because again we are concatenating the current value of the string and two dashes and whatever the index I is in the current for next iteration statement, and we're assigning that back into string. So this operation of string equals string and something new is actually very memory intensive. Now in a small example like this, it's nothing to worry about. But if we had lots of strings to work with, lots of string concatenation or replacements of characters and things of that nature, it becomes kind of problematic. See, strings are immutable, meaning that whenever you create a string, it's like an array of characters. That array is fixed in size, and it can't be just the size of that bucket in memory can't just be expanded without there being some impact in the system. So what's happening behind the scenes is that the .NET framework is managing the memory for the myString variable. And it says, okay, myString is this size. Okay, got it. We're going to create a bucket memory for that size of a variable. Oh, wait, you want to take that variable and add more to it? Well, what do we do now? Well, I guess I will temporarily create a new place in memory. I'll take the old variable value, I'm going to attach this new stuff to it, and I'll put it in this other place, and I'll get rid of the old one. So now we've got the new value. Great. Oh, wait, you want to add more to that string? Oh, we got to do this dance again. Okay, I'm going to create a new area in memory. I'll take that value, append more to it, and stick it in there. And so we keep doing that over and over and over, and that's very memory intensive and very processor intensive. And so there's actually a better way to do this, and I'll talk about that in just a moment. But before we do, I want to show you one quick improvement to this code using a new operator that we haven't talked about yet. Let me show you the plus equal operator, which says take what I currently had and append this to it. So I can just do this. And this will work with integers as well. So I plus plus or I plus equals will work with that value as well as an integer, right? CSTR I. All right, so when we run this example, we get the same result, but we did less typing because we didn't need to do this whole little dance right here. All we need to do is myString equals plus equals means take what you currently got and add all this other stuff to it. All right. But as I said earlier, that's memory intensive. So let's take a look at another way to kind of remedy this. There's a preferred solution to the scenario that I described when you're working with lots of strings and you're doing a lot of string manipulation. Maybe not something as simple and silly as this example, but something larger scale. There is a class in the .NET framework to build strings, to handle strings, and do it in a more memory efficient manner. And so let's go ahead and rebuild this example with working with the StringBuilder class. So here we go. Okay, so notice that. Okay, so we get a blue squiggly. We'll come back to that. We know how to resolve that, right? So in this case, let's go ahead and resolve that now. We're going to import system.text where the StringBuilder class resides. We'll import it so that we can use the full name. Notice it adds the import system.text line of code to the very top of the code file, and now it sees the StringBuilder. So now we can do something like this: mystring.append, and we'll just add dashes, and then we'll go mystring append value of I, and then we'll print out my string. All right, and so we get the same result. However, it is much more memory friendly in this particular case. All right. Let's take a look at this where we've actually created a new instance of the StringBuilder. You might wonder about the purpose of this new keyword in line number 26. We're going to talk about that at length. Actually, line number 21. We'll talk about that at length in an upcoming lesson about classes and objects. For now, just accept the fact that we need to use that operator, the new operator, to use the StringBuilder class, at least in this capacity. All right, and so again, the result will be the same with this little code snippet as what we saw earlier. However, the impact on the performance of the application on your computer will be dramatically reduced, especially when you're dealing with a lot of text, not just the silly example, but I'm talking about a lot of text. And so it's generally preferred to use a StringBuilder rather than a string whenever you have a lot of string concatenation or string manipulation work to do. Okay. So finally, we're going to look at how to work with some of the built-in string methods to manipulate strings. Again, there are a lot more than what I'm going to demonstrate in the next couple of moments here, but these will at least get you familiar with what's possible. So let's take a look at this. I'm going to actually comment all of this out and start over again. And you can use any string that you want to here. I'm going to quote the line from one of my favorite songs. And notice I've added some extra spaces before and after that sentence. Okay. And now what I want to do is, first of all, I want to capture just a subset or a substring of that longer string. So I want to analyze maybe each individual character or individual words or phrases, and so I can find strings or parts of strings inside of the larger string using the substring method. So the first argument that we're going to use is actually the starting index, the zero-based index. If we were to look at this as an array of characters, where do we start inside of that string, and then how many characters do we pull from that string into our new substring? All right, so we're going to start at position 14, so we're going to use index 13, and then we'll take 15 characters and then print that in a console.write line. So we were able to take the phrase out called "we took threes" from the longer string using the substring method. Okay, let's comment that out. Next, let's look at, I think we've already done this one time. We're going to use another method called toUpper, and that will put our entire string in uppercase. There's also a toLower, which will make the entire string in all lowercase. And you might be wondering, why would you want to do that? It's because whenever you try to compare two strings against each other, if you have a one that's uppercase and one that's lowercase, those strings will not be equivalent in Visual Basic. So to prove this idea, take a look at this. Let's just do if upper equals upper, then console.writeLine yes, else console.writeLine no. All right. So when we do this, you can see that no is returned. That's because lowercase and uppercase are not equivalent. And so we use to upper or to lower to take, like, for example, input that the user types in to your application. We want to compare it against some string that we're expecting. And so to compare apples to apples and oranges to oranges, we want to either use the to upper on both strings and compare them, or the to lower on both strings and compare them. Okay. Either way will work. Great. All right, and so next we'll do something like this. My string equals my string dot replace. And suppose we want to replace all those empty characters, all those spaces, with another type of formatting like double dashes. Then we can use the replace character. Now we've taken and gotten rid of all the empty spaces and replaced them with double dashes. And this is actually much more convenient and much more useful than you might think, because whenever I'm massaging data, say I open up a file from one system that was produced on a Unix system, or for a different program that was created in my company, and now I want to massage the data, I want to change some things around about the data and put the file into a new format that can be utilized by a different operating system or a different program in my enterprise, I might want to use the replace a lot to kind of to move things around and massage data and so on. So I use that replace method quite a bit. Okay, and so for the last manipulation I'm going to perform, I want to demonstrate kind of the use of two methods together. So let's do this. All right, so that's my little template, and now I'm going to pass in, first of all, what is the length of my string? And then the second, I'm going to do the length of my string. I'm actually going to call trim. So there's several of these trim functions. There's, I think, trim start. And there's trim end. And so we can either trim off the trailing characters or the preceding characters that are spaces, so that we can kind of remove all the blank spaces. So that's why I intentionally put blank spaces at the beginning and the end of the string, because I knew I was going to eventually trim them off. So we're going to look at the original length of the string, and then we're going to trim off one character at the beginning and two characters at the end, and I would expect that the new length of that string, how many items are in that or characters are in that string, would be reduced by 3 for the after. That'll be replaced into our string.format. So before, there are 47 characters, and then afterwards there are 44 characters. All right, great. So as I said earlier, these are but a smattering of all possible string manipulations. However, this short list should serve you pretty well. I would encourage you, before you go off and you start writing lines of code to work with strings, take a few moments and review the methods of the string class and what's available to you. Chances are that there's probably already a method or two that can, at the very least, provide a very good starting point for you. I've seen people write some elaborate code to perform some string manipulation when all they needed to do was call a single method on the string class. And so it's just sometimes you're not familiar with what's even available to you from Microsoft. So take a few moments before you start working with strings and think, I wonder if there's already something built in that will handle this string manipulation I want to do. And then do a little bit of research using IntelliSense, using MSDN, and that should help you find some clues as to what you can kind of piece together to get the result that you want. All right, great. So we're going to look at that date and times much in the same way that we've looked at strings in this lesson. So we'll see you there in the next lesson. Thank you.